Hello and welcome to the show, Chris.
Good morning. Good to be with
Good
you.
morning. Happy Friday. We are just about to step into a long holiday weekend, and this book is a perfect little read. Congratulations. This new book, Grace in All Simplicity, well, new to us, not new to you, of course, is beautiful. Let's start with the title. You found such a gorgeous title.
Yeah, you're very kind. I'm not sure it's exactly beach reading, but why not? It's,
Well, for nerds, I
it's
think it's
certainly
perfect.
certainly a little bit of escape. So the title comes from a poem by Shakespeare called "The Phoenix and the Turtle," in which there's a very nice line with an excellent cadence that goes beauty, truth, and rarity, grace and all simplicity, and then continues. So I like the cadence. Beauty and truth we all seek. Beauty and truth were also the original names for the bottom and top quarks that didn't stick. Bottom and top were less lofty, but more practical, I suppose. Rarity is a characteristic of many of the experimental searches that my colleagues do. And grace in all simplicity evoked for me and my co-author, Bob Kahn, the current understanding we have, what's called the standard model of particle physics, which is very easy to state compactly. There are a small number of rules, small number of insights that we begin with to calculate and elaborate the consequences of those rules, which comes close to the whole world we live in, is no easy trick. Nevertheless, we find the equations graceful and simple in their own way. So that was our working title, and happily for us, our editor loved it, and there it is.
There is. Now, you had just mentioned this beautiful word that is also drives fear into many non-science, non-math majors, equations. And you have none of them, absolutely none in the book. Why is that?
So you're right. I mentioned equations, and we noticed that that can be scary to some people, and also that in some earnest books, people use equations more or less like wallpaper. So they're there. You're supposed to look at them and be impressed by them, but not necessarily to have to deal with them. Our goal from the beginning was to write something that would be attractive to readers of the New Yorker. So long form nonfiction. We have no equations, as you state. We have no footnotes. We have no illustrations. We have no graphs, nothing like that. And so the challenge for us was to try to meet the standard or approach the standard of some of the excellent essayists that you can read in the New Yorker, people who will present with you an idea that you had no idea you cared about and interest you in it and explain the essence of it and some of the depths of it simply with words and an elegant presentation. So that was the hypothesis from the beginning, what we set out to do. And very few people have complained about the absence of equations.
I would agree. I would agree. As a matter of fact, I'm not speaking up at everyone's behalf, but for me, reading this book was beautiful and poetic, and your word choice and the way it was outlined and presented, and it's not chronological per se. Can you walk us through why that is?
Yes, for two reasons. One is there is a value to what some writers call a braided narrative, in which you take something from this, something from that, and you see eventually how they come together. The other aspect for us is that the way physicists who are doing research and creating new ideas and new knowledge work is not in a linear fashion. You know, you may hear an idea at one point, it doesn't really register on you. Later on, you can make use of it. Something from another field may be presented to you, and suddenly that makes sense, that's something that you could use. And so what we tried to do was to have that complicated braided network of ideas and discoveries, and to show that this is really the way we think and learn.
I love that. And I think more and more students learn that way these days, a little from here, a little from there. And when we're inundated with everything possible on the internet, sometimes it can be very difficult to filter or categorize and say, this lands here, this lands there. And maybe that translates perfectly into science study.
I think it does. Especially in the technology that my colleagues use to build accelerators and do experiments, very often the essential insights come from another field. People studying superconductivity, a discovery made a little more than 100 years ago by accident, by somebody
Mm,
who was pushing the frontiers by going to lower temperatures ever before and trying to investigate how materials behave. It took a long time for that to be domesticated and used in the Tevatron accelerator at Fermilab, now the Large Hadron Collider at CERN, MRI machines that you may have experienced or may at some time in your life that rely on the strong magnetic field produced by superconductors. So this is work that was done off to the side of us looking for the fundamental constituents of matter and their interactions, but it's essential in enabling us to do the experiments that we do. And superconductivity is a particularly interesting example from my point of view, because not only is it enabling technology for the accelerators and the analysis magnets in the experiments that we deal with, it also incorporates an idea that lies behind the famous Higgs boson, the particle that gives mass to other particles and accounts for the diversity and change that we see in the universe. So it turns out that an idea put forward 70, 80 years ago to begin to understand the phenomenon of superconductivity is just the hint that we need to apply that in a different setting and apply it to our theories of the elementary particles. So things
lovely.
come together. I often tell students, they ask me, what should I study? Should I study this? Should I study that? Well, the answer, of course, is everything, which doesn't sound that helpful. But it is true that the more you have a respect for different kinds of science, mathematics, technology, the more you're prepared to take advantage of a good idea when you hear it.
I love that. Lifelong learners. That's what I try to encourage everyone. I still am myself.
Very good.
One of the things that I think we can all learn from and enjoy throughout your book, and I cannot wait to hear how you and your co author came to this, is to celebrate and share the narrative of the people who were behind some of these equations that were not included, but some of the ideas and discoveries. It's a real beautiful narrative through people's stories, and one that I found delightful because if the science eluded me, then it was the people that I connected with. And when you and I met, I laughed and enjoyed so much the idea behind the fact that I'm breathing in Cleopatra's atoms. Can you explain that chapter? I feel so connected to history and
So
science.
I
It's
can't
wonderful.
say that we can prove that this happened to you today, but but it's very likely to happen to you sometime. So the this was in the chapter about atoms, and a very remarkable young experimenter in England who found a technique to order the atoms, the different elements, and to know which one came first and second and 25th and 92nd and so on. And the essential notion of atoms, which goes back to the people who made up the term uncuttable things, is that they are forever. And under almost all circumstances, they really are forever. So the little conceit that we had was famously, Cleopatra had a legendary nose. Through her nose, she breathed a lot of air molecules. And if you do the numbers, it's overwhelmingly possible, likely, I would say, that some of those air molecules have circulated around the globe, retaining their shape and form, and ended up in front of your nostrils so you could breathe them in. So if
That's
it's not
really,
exactly true, it should be true, but I think it's
I
very
agree.
likely to be true.
Well, I like it because it helps me connect to the concept, right? to think of something that has existed and will continue to exist and continue to inspire. And that's what you've done throughout the chapters as well with these human stories. But importantly, they are people who made such amazing discoveries. And you've had a wonderful opportunity to walk through and present them to us, some of which I had never heard. Can you walk us through and tell us another story about some of the most brave people I've ever heard of who, I don't know, wanted to think it was a good idea to play with lightning at the top of a mountain on a cable?
It worked for Franklin, at least in legend. So let me
Right?
preface this by saying that Bob and I are both theoretical physicists. We've known each other since graduate school. We've both had the opportunity to work all around the world and meet really remarkable people. And through them, through some of our teachers and some of the more aged people that we have met, we have learned, at least secondhand, about the people who preceded them, who were their teachers and so on. And I think because of that experience, because of our exposure to many exceptional people, we have gained a respect for these people and begun to think of them as human beings, not just as icons, and try to take lessons from them. I will get to the boys on the mountain in just a second, but I want to say that one of the things that is precious in doing science, and this can happen at tiny levels, if you're lucky, medium levels, if you're really lucky, gigantic levels, is to find that nature takes your ideas more seriously than you do. You have an idea, you think it's pretty good, you put it out there, and even though physicists in particular have a reputation, not really deserved, for being self-confident, arrogant, and things like that, we're a bundle of contradictions. And so one of the most delicious things is to find out that nature takes one of your ideas more seriously than you do, really has implemented it in some way. And one of the things that we discovered in the course of many, many more examples, and as we were writing the book, is that some of the people who have made iconic discoveries in the past wouldn't quite bring themselves to believe them at first. We think of people of being very possessive of their ideas and saying, well, it's my idea, it has to work this way. And I would say they were enthusiastic about their ideas, but often they had second thoughts. Is this really too big an idea to be true? What are the implications of it, and so on? So we begin the book, as you noticed, with some wonderful characters, three young physicists from Berlin, who in the late 1920s, after the atomic nucleus had been discovered and Harry Moseley had put the nuclei in order, people wanted to find out, well, what's inside? Can you take it apart? Is it made of anything? So this was an imperative for people. It was held up a little bit by the First World War. Science came to an end, but then in the 20s, people became serious about this. And it stood to reason that if you could make very energetic projectiles, so alpha particles, so helium nuclei or protons or something, you might shoot them at other nuclei and break them apart if they would come apart. It wasn't known whether they would come apart. So these three guys, whose names were Arno Brosch, Fritz Lange, and Kurt Urban from Berlin, did some research in meteorology. They discovered they wanted to use atmospheric electricity, which is a fancy name for lightning, to produce high voltages and somehow harness that to accelerate particles and smash them into atoms. So they did some meteorological research and they discovered that there was a unique place on the Italian-Swiss border called Monte Generoso. It's above Lake Lugano, so near Lugano in Switzerland, and it had the combination of being one of the most thundery places in Europe. They have thunderstorms every other day in Monte Generoso, whereas in most of Europe, it's 15 times during the summer, so not as common. And there's a rack railway that goes to the top, so they could move their heavy equipment up there by the rack railway. So they had the idea of building basically a large antenna, a net of iron wire that they built from the summit across to another peak. And the idea was that this would capture electricity at high voltages and allow them to use them for their experiments. They discovered that even in the conditions of normal weather, the atmosphere does have an atmospheric potential, an electrical potential in it. In fact, in our atmosphere today, it's about 1.5 volts per size of a 1.5 volt battery, all the way up, because there's more charge, one kind at the top and the other kind at the bottom. But they discovered that during thunderstorms, they could really get to 15, 18 million electron volts.
Gosh.
And so they were fascinated by this. People who were there were accounts of this in the New York Times, the local newspapers, and so on. And there's a lovely centerfold in Popular Science of the time that shows a picture of their apparatus and of one of the three, Kurt Orban, who was the one, I guess he was the junior partner. So they had a metal hut, which was their counting shack, if you like. And he would sit in there, and by a lever and ropes and so on, he could raise and lower a device to try to make sparks of different length and measure the voltage that way.
Gosh.
So he was advertised in Popular Science as the most shocked man in the world.
Oh gosh.
It is said that lightning doesn't strike twice in the same point, but it seemed to strike hundreds of times
right.
in this apparatus if you play your cards right. So that was the great success of the first year. The second year, they went back, having refined the apparatus and having developed in the laboratory in Berlin some devices they were going to use to try to do the real experiment. And sadly, during that experiment, Orban himself, trying to fix the apparatus, fell off it and into his death. So they weren't fools. They were careful about what they were doing. We took them as an example of the lengths to which scientists will go. You know, some of our colleagues have built a neutrino observatory at the South Pole in the ice. Other people go here and there. In your principal interest of space, people go out there, and we send probes way out there to do our work for us. So they captured our imagination as embodiments of people who would do whatever it took to try to get the answers.
You yourself went back to visit this place. What was that like?
I did. So it was fun. I did make a pilgrimage there, and I took the rack railway up. The hotel that was their headquarters still is there. It was rather amusing for me because I was the only guest other than a guitar society from a tiny Swiss village called Finn, Pfyn. So I was surrounded by these people strumming their little guitars and singing songs in Schweizerdeutsch.
Oh gosh, you were serenaded.
I was serenaded.
Expedition.
But I got what I came from because there was indeed a very dramatic thunderstorm that night. So as we described it, the canyons are rocked by the sound of thunder and so on. Amazing. And when I woke up in the morning, indeed, the sky was clear. All the dust had been washed out of it. The clouds were gone. And you could see the Matterhorn and other mountains around. So just as described in our opening chapter, not everybody risks his or her life, but many people put themselves out in the service of science and are committed in various ways.
Yes, people can say that. Well, you certainly have shown that throughout the book. You've talked before on other shows as well about some of the women and their journeys and how incredibly intelligent and brilliant. And you talked so elegantly here about how you might not feel the confidence per se of your idea, but when shared or discussed, and nature envelops it and takes it forward. I really love those stories as well, that perhaps there were many things going against a lot of people at the time, be it the equipment not up to par, the place and status in which some of the females were in their careers, where they were battling against their heritage or just being a woman in science or being able to attend lectures. And yet, all of this science and nature, as you share, persevere. Um, these are the beautiful stories that I've so enjoyed in this
Oh,
book.
I'm glad because it's quite inspiring to us to feel a connection to these people. As I say, through some of our teachers, we know the greats of 2 generations ago, Enrico Fermi and people like that. Somebody who was dead
Yes.
while we were still playing pickup baseball games and things like that. And it is, I hope that, one of my regrets is that although both Bob and I have been pretty attentive to these things, we were surrounded by people who were there or knew the people who were there. And we learned a little bit from them, but from our wise elder position now, we should have learned more. Should have spent more times with them and asked them more probing questions. But we
Always
got
that
what we could.
feeling. Well, you never feel done, right? I mean, even this book, it'll probably evolve as more things are discovered, right? In quantum physics and in the world. Do you ever feel done? I mean, please, I know you travel and you've been a teacher and you've been exploring and you're a wonderful writer. So I think that feeling of never feeling done is good, right?
It's very important. People sometimes talk about the final theory, or there are people, I think they're not very numerous among scientists, who want to have the last word.
Mm.
And for me, and I think for Bob, being part of the progression, learning something new, maybe not every day, but every year, is a good thing. And contributing to the development of knowledge, it'd be pretty arrogant to think that we could get to a final answer. And
Oh,
even if we did, suppose I gave you by divine inspiration all the equations that govern the world. Well, there's still all the consequences of those to work out. An applied science problem, an engineering problem, to explain why the world is the way it is, to try to come to terms with the complex systems, with life, and so on. So I think there will always be questions, and I suspect there will always be questions in the physical sciences. And it's just a thrill to have been part of development that over the time since we were in graduate school until now, the science is unrecognizable, and I hope it will continue to become unrecognizable.
yes. I loved when we got to chat earlier a few weeks ago in the coffee shop. Uh, and you had said something, a beautiful quote I'd like to share in this very regards, that people have a naive faith in the value of exploration, and we owe them to tell them what we find as scientists and explorers. So you've certainly done that here in this book, but when we talk about, as you mentioned, what's in the future of the application of the things in which we find, whether here on Earth and minute, very small particles or larger in the universe expanse, this feeling and owing of exploration is beautiful. And then we truly are never really done because we always have to turn around and share it with everyone.
Yes, it's one of the great thrills that I've learned this not only in lectures around the United States, but in other places, that everywhere you go, there are people who want to meet a scientist. I mean, in the space world, everybody wants to touch an astronaut.
Oh, sure.
They're sort of magical. Well, we're a little less magical, perhaps, because we haven't put on those funny helmets. but people want to meet scientists. They want scientists to take them seriously. And it is, I think it's a characteristic of some young people in science to think, oh, the public doesn't know anything, they don't care. If you actually meet them, they care quite a lot. They may not speak our language, but they have great curiosity. There are family members among others.
Yes.
They have
Yes.
great curiosity, and they want to be treated like grown-ups and to be let in on how we think. Now, to do that, we have to get away from our scientific shorthand and, all the thoughts that we've gained over 2,500 years and crammed into our heads. And that's a challenge for us, but it's quite a worthwhile challenge. And in public lectures, even in the small meetings, I've been doing the book events where typically it's 20 or 30 or 40 people, not in a big auditorium, but in a bookshop in which they feel comfortable because they've been there before. There are people who just want to know and want to feel connected, maybe have their own ideas of the way things should go and want to discuss those. Young people who I just find it thrilling to read a book about science that comes to them on their terms and to meet a scientist. I had the good fortune to be exposed to such books when I was a child. Public libraries and bookstores are great institutions. They really represent the soul of our communities. And I think all of us who had that experience as children, teenagers, before we even knew what science was, to sort of think that we had an interest in it, to feel that in the pages of Scientific American in the old days or in some of these books, that a real scientist is speaking directly to you. So
Yes.
Bob and I also had that in mind, not exclusively to the teenagers, but we wanted to remember that there is a 14-year-old science geek boy or girl out there who would like to believe, and we'd like to make it true, that we're speaking to them.
Absolutely. I think CERN is magical. I think there's magic at Fermilab. And I think certainly through the years and giving your lectures, or if you ever sometimes the national labs will have these wonderful open house days where families and students and people from everywhere, the public comes in and they get to see a little behind the scenes, and you just never know where that's going to land or who's going to be inspired or who starts asking a little more questions. And having just the very vicinity of people like you or, the scientists, the managers, the facility directors, they're all there to help guide and answer those questions. And again, you never know where that lands. For me at Space Camp, way back in high school and before, we would have a very special guest come in and help give a brief graduation blessing, if you will, and good luck message.
Mm-hmm.
And one of them was an assistant who worked alongside Werner von Braun. Now, it didn't matter to me that this person was not Werner von Braun. It was someone who had worked within the very vicinity again, or lab or ranks. And to me, it really moved me. I just felt so inspired. And through your career and through all the many and incredible scientists and people you've been able to work with and writers, again, I want to go back to the poetry that you presented in this book as a writer has just been it's magical. You use that word, and I think a lot of people will find that in this book.
Oh, that's very kind. Well, let me make a remark about CERN because they made a recent very large investment. The director general was able to raise 100 million euros or something from private funds to build a new science gateway. And they now are getting hundreds of thousands of visitors per year. Geneva Advantage in the New York Times, and there are 52 places to visit this year, named Geneva, but the photograph they showed was of CERN, so it is a real tourist attraction. So I had on a recent visit there, I had the chance to go through the Science Gateway with one of the young people who had helped design some of the exhibits. And my interest was less in the exhibits than in the people who were interacting with them. And of course, there are kids, there are school groups there, and some of them were in classrooms, some of them were wandering around with their parents or on their own, but also a very interesting number of people of what in France is called le troisième âge, the third age, which means retirement people.
Ah, yes. Okay.
Were there and finding opportunities that maybe they hadn't had before to interact with a demonstration, a piece of apparatus. And then if they turned around and looked puzzled, there was a young person who had a role in designing that, to have a conversation with them. And I hope it's thrilling for the people who visit. I know it's thrilling for the scientists who get these questions, and to reinforce for us and for the young scientists the idea that what we do really matters to a lot of people, even if they couldn't explain to you exactly why. We're really
Is thrilling.
part of the construction of civilization. And that's why I take it as a responsibility to come home and to tell people what we've discovered and what we're puzzled about and so on. They are paying for it as taxpayers, of course. So there's that idea, but it's just that they are giving us moral support and we need to give back. And it's
That
really
is
fun.
thrilling. What is it like going to CERN? I'd love to go. Is it overwhelmingly larger than we're conceptualizing, or is it intricate? Is it, do you feel enveloped and like very small or very, what is it like walking through there?
Well, I went for the first time in 1971 when I was a kid, well, as a postdoc. And it has been essentially my second scientific home ever since then. So I go there quite regularly. I've had a lot of involvement with the place, and I've always been treated better than I deserve, which is a nice feeling. Um, so it is a lab. I would say there are maybe 3,200 people on site every day. So that's considerably larger than Fermilab. The instrument itself, the main instrument, is a ring, a circle, 17 miles around, 27 kilometers around, underground by 100 meters, and so you hardly know that it's there. But the devices are very large and very impressive. I should have brought some photographs to show. I mean, I have to say, when we made our decision not to have photographs and drawings, it is something that we're happy with. And I think the reason for that, other than the challenge that we set to ourselves, is it may be true that a picture is worth 1,000 words, but for some of these pieces of apparatus, a picture requires 1,000 words of explanation. and
Sure.
that's a different and worthy way of approaching the problem or the opportunity, but it's not the one that we wanted to take on. Anyway, these pieces of apparatus go from the finest electronics you can imagine to detectors that are 40 kilometers long. They're the size of 2 Viking ships and made by thousands of people. They fit in caverns that are 5 or 6 stories tall. So they're made together by people from all over the world, which is another inspiring thing. One of the great things about the science that we're involved in, I'm sure it's true in astronomical explorations and space explorations as well, is that we get to work with people from everywhere and meet people that normally we wouldn't run into and discover things about them, their way of thinking, their way of talking, the food they eat, all sorts of interesting things.
That's those stories. That's what brings us together. It's true, certainly in your field, and yes, in science, in exploring space, because anyone who ever made any widget, I'm using terrible air quotes, anywhere from any contract that knew would go to NASA or get flown or be part of building an international space station, the pride, but also the connectivity of just saying, I was part of it. I feel honored and understanding space and science a little more, and then carrying that on and telling communities and families. And again, you just never know where inspiration lies, so that other next generations can just point to something perhaps tangible or intangible and just say, my dad, my father, my mom, my aunt, uncle, was a part of this.
Yes, it's really wonderful. Let me note that if you find yourself in Geneva, you take the advice of the New York Times and make that one of your 52 stops during 2024. There are regular tours for the public at CERN. Most of the equipment, the accelerator is running most of the time, and most of the equipment is underground. And when the accelerator is running, of course, there's a radiation hazard down there. but not in the rest of the laboratory. So only on a few occasions throughout the year might you have the great opportunity to go underground and almost touch, look,
Oh,
but don't touch the
right, right.
apparatus, or at least be in the company of people who have touched it. But on most days of the week, you will be able to take a tour of the laboratory and meet some scientists and other people who are there from, I think CERN just added another member state today. Estonia just joined as a member state of
Oh,
CERN, and they're up to something like 30 or so different full member states now. People who contribute to the budget and have staff members and so on.
that's so
So it's a
great.
growing organization, really a great place. Fermilab has a science center mostly for children called the Letterman Science Education Center. That's open 5-6 days a week. They have tours for school children. And so a lot of people who've grown up in this area have gone there either to hear about science, physics, or one of the things that they did that was really fun for students and teachers was to study the prairie. We have restored prairies at Fermilab, and so kids would come out and count the different insects and look at the different species of plants and things like that. And it wasn't a 2-semester course, but it was hands-on science of a kind that I think is quite memorable.
Awesome. Yeah, there's so many ways that people in public can take tours and interact, both at national labs. If you live near one, highly recommend. But I always say this too about academics. If there's a university or college near you, there's usually a planetarium and all kinds of labs and
Indeed.
opportunities for you to step in, and they host all
And
kinds of open
lectures
houses.
that are open to the public.
Yes, yes. Okay. Well, now that we've started the first half, I think, of the book, and then stepped into CERN and Fermilab, there's a whole future. I would say one in your message here that you've captured is one that is hopeful. And certainly in our lifetimes, yours and mine, to see an international space station go from conceptual to being built and assembled and operational, to see CERN, to see the things that not so long ago were in theory and now are, showcased, and also peacetime experiments into fruition. Would you say that the future is one that is hopeful?
I'm very hopeful. Um, in many ways, the world is going to hell. It's probably been going to hell for many generations. Many people have had to deal with much greater challenges than we have. We do have challenges on Earth of the dealing with the environment and being responsible stewards of that. There's war, there's pestilence, there are all those things. But overall, and in particular in this country, we are very wealthy people as a society. There are challenges of inequality, there's all that stuff that responsible citizens should care about. But we have the opportunity, we have the means to do many great things. And among those great things is exploring, learning more about the world. In some cases, we will learn something about the world that we can then harness for good or evil, let's hope mostly for good. In other cases, in the short run, it will be knowledge, understanding a little better how the world works, learning that the world, in spite of all the evidence before us, actually follows rules and can be understood. This is one of the great miracles that is encouraging to people who do science, that we feeble people can actually comprehend a great deal about the world and can make progress. So that's part of why it's exciting to be a scientist. I hope it's part of why it's exciting to be a citizen who can witness and participate in the discoveries of science. It's one of the things that we do that contributes to the development of our culture, not exclusive, science isn't everything. I'm frustrated a bit when people emphasize the need for STEM education, because all that's important, but it's good to learn to read novels, write real sentences,
Yes,
learn
yes.
how other people see the world and so on. So I think we should be study foreign languages so you can interact with people in their literature in the native way. There are many things we could be doing better. And I think they all consist in opening ourselves to the world and to what the world has to teach us.
Yes, very well said. I'm very grateful that it is one of hope, even despite, the challenges ahead. I always like to ask as we wrap up, if there were any surprises that you found while you were researching and writing the book. Is there anything in your career or anything that you continues to surprise you as a lifelong learner that you can share?
Well, there have been many surprises in my career. Some of them were just experimental results that just weren't the way I thought they were going to be. Some of them were, one of the chapters in the book is called Revolution. I think it's chapter 6. It's about discoveries made about 50 years ago, this November, of a new kind of particle called the J by one of the groups that discovered it, the psi, Greek letter psi by the other. And that was one of these cases in which there were many ideas floating around. They were interesting ideas. Lots of us were playing with them, some in a really playful way, others in a more serious way. And we didn't know whether they were going to turn out to be true. And we didn't know whether one or two of them would turn out to be true, or as it happened, essentially all of them turned out to be true and to fit together. And the catalyst for that understanding was the discovery of this remarkable kind of particle. So that was, in a sense, as I say, this was in our heads. It's something we're talking about all the time, these different aspects of it. So it wasn't a total surprise, but that's in a way why it had such resonance, because it said, pay attention, all these ideas actually mean something and have something to do with each other. So that's a very dramatic example. The discovery of the Higgs boson is something that was a preoccupation, an obsession for me for nearly 40 years, 35 years, I think. And it was the way things were likely to turn out, but it wasn't guaranteed.
Mm.
The world could have chosen other ways. And so on the day that we finally got the news, 4th of July 2012, when there was an announcement from two groups at CERN that they had found this particle that was just like what's in my textbook and many other places, it was really wonderful to think that the equations that you write on a blackboard in chalk, which take, great contemplation, but no great physical effort, can lead people to spend decades of their lives building equipment, bringing it to life, doing experiments with it. And at the end, you get an answer. The answer sometimes is no. In that case, the answer was a resounding yes. It's immensely satisfying. And immediately, shortly thereafter, I was back at CERN. I was with the spokesperson of one of the experiments, a good friend named Fabiola Gianotti, who's now the director general of CERN, and a film crew was following us around. And so we sat down in the Atlas control room, and she turned to me and said, "What do we do next?"
Oh, yes.
And I was really mildly annoyed because that was my question for her. What do we do next? Because that is, you get to a certain point. It's like when you're climbing mountains, you get to a high point, you look out, you can see other places that you might be able to go. And that's a situation that we were in then and remain in now. We closed the last third of the book. It has to do with things we don't know. And a couple of those have to do with space, cosmology, everything that's out there. So the famous dark energy, whatever is the medium that's causing the universe to expand more rapidly than it should on the old way of thinking. So that's very mysterious. And as we say in the book, that is the greatest discovery ever, because it's about the whole universe. So what could be bigger than that?
Right.
So we tease our friends who made the discovery that, they're the champions forever now, in that sense. There's the mystery of dark matter, so-called, this stuff that almost surely exists, that is in addition to the stuff that you and I are made of. It's a good fraction of the universe, 25% or so. And we can see its effects, but we haven't been able to isolate it yet. And then there are other questions that have to do with the way the world behaves that we'd like to get to the bottom of. And I'm sure in the next decade or so, we will make, I have a list of now 120 questions that I show in seminars, just to remind people that the field is very broad. And I'm sure that in the next decade or so, we will get to a dozen or so of the most important of those.
Yes. So much learning yet to be had. And thank you for capturing your journey and the journey of so many others in your book, Grace in All Simplicity, and joining us here today. I love it. I hope that one day I can get to CERN, and I would be honored to meet you there and have a coffee and continue our conversation. But I thank you so much for today.
That would be fantastic. It's been wonderful to meet you, and I am happy to have the chance to talk to your listeners.
Okay, will do. Well, you can find Chris in the links that I'll provide here in the show notes. Thank you again, Chris.
Great to be with you.